Hello friends, today we will learn about storage classes in C. So in C, storage classes has been divided into 4 categories. First one is auto, second one is register, third one is static, and last one is global. So these categories has been created based upon their properties of where they will be stored, what will be their scope of access, what will be the lifetime of that variable, and what will be the initial value if you don't initialize. Okay, so let's start with auto. So auto variables are the default storage type for your variable. If you don't explicitly mention the storage class, so it will be auto, and storage will be on stack. Their scope will be within a block. When I say within a block, that means, let's say if you have a if block and you have defined a variable within that block, you cannot access out of that block. So that will be your block level access. Lifetime of auto variable is again within that block where it is defined. As soon as you go outside of that block, that variable will be destroyed or it will be deleted from the memory. Initial value for auto variables is 0 or garbage. In older compiler or many compiler actually, default value of auto variables is garbage, but you will find some latest compiler or like GCC, there you will see it 0. So let's see it in our code. How do it behaves when you declare a variable as auto. So for today's session, I am using Ubuntu terminal which I installed from WSL because I want to show some more details about these variables, how they look like in object file. So let's create our program. So as I said, our default type for any variable is auto. So if I say int a, so by default it will go into auto category. You can also explicitly mention it like this, but even if you don't mention it explicitly, it is going to be your auto until unless you define any other storage class for that. So if you see here, I am not initializing it for now. So let's see how it will behave, what will be the default value for this variable. So that's it. Let's compile this. So we got our output. If we run out, so you see here it is printing 0. So in GCC, if you don't initialize any auto variable, they initialize it with 0, but this is not guaranteed behavior. So I will recommend for auto variables to always initialize with some value. Otherwise you may end up getting some unexpected results. Okay, I can show the similar thing in Visual Studio. So in Visual Studio I have same code. If I run here this code, I'll get the error. What it is saying, the variable is being used without being initialized. So if I ignore this error, it will run and it will give me some junk value. some garbage value. So auto variables default value is most of the time it is garbage value, but few compilers are initializing it with 0. So do not take that chance. Always initialize your auto variables. So we have seen the default value of our auto variables. Now let's see their scope. So as I said, the scope of the auto variable is within a block. So here if I create a block, this declaration, if I enclose it within a block, then this access, here we are trying to print a, right? So this particular access of the variable which is within this block will cause me some problem. So if you see the here, if I try to compile this, I got the error. Okay, error a undeclared first using this function at line number 8. Okay, so we got the error at line number 8, and this is my line number 8 where we are printing a. Okay, so that is with auto variable the scope is limited within the block. Okay, now if I, let's say, create another variable over here, same name, let's see now how it behaves. So it has compiled successfully. Why? Because if you see, I have declared a again out of this block. So for this printf a, it will take the value from this this declaration, not from this one. And if I try to see the same, so now let's run this. We compiled it. Now let's see what it will print. See, it is printing 5, which was before the block value. So it will not be modified here. It's different value, different variable, and this one is different variable. Although the name is same, but both are different because their scope is different. This lies only in this scope and this one is in different scope. Another interesting point here is, what if I delete this and I just simply change the value of this block over here. So this is totally fine. In this case, since we are not declaring anything within this block, which will be called as local scope. So if some variable or any variable is not present in the local scope, it will look for the one layer above. Why? See, this is first block, and within that this is the second block. This is nested block, right? So if something is declared above, that will be acting as a global for this block. So if for a there is no definition present within this block, it will go and look for its parent block, and if it is present there, it will use that declaration, it will use that variable. If I am right, we should see the output of this statement as 10. So let's compile this and run this. See, we got the 10. So I hope this is clear. If anything is declared within a block, though variable name is same, it will be considered as a separate variable. But if variable is not present in the local scope, it will go for the parent's scope, parent's block, and if it is available there, it will take the definition from there. If it is not there, then it will go one layer above. So it will keep going until it scans everything. So if anything is not available in local scope, it will go one layer above in parent scope. If it is not there, then it will try to go one layer above again, and it will keep going in nested blocks until it finds, or if it doesn't find, it will throw you an error. So now let's move to our next storage class, which is register. So registers, as name suggests, it gets stored on registers. Which register? CPU registers. So each processor has their own set of registers to do operations, to whatever mathematical or logical operations are there, they have to store the values. So they have their own register, and for your operation, let's say if you say integer a equals to 5, and then if you do a plus 5, then a will be loaded into some register, maybe you can call it accumulator register or some different register. So it will be, the value of a will be loaded into that register, and then 5, since you are adding it with 5 will be loaded into another register, and then it will do the operation add over there. So this comes in assembly programming. There you can learn all about this, how actually through assembly programming you can actually deal with CPU registers. But here just understand, if you declare any variable as register, system will try to create those variables on register, but this is not guaranteed. It will only try if there is no register available, or the size of variable, if let's say you are creating a big variable on register and that much space is not available, then it will create the variable on your main memory. Scope wise, it is only accessible within block. Lifetime is again within a block. As soon as you move out of block, variable will be destroyed. Initial value is same as your auto variables. So now if you see here, the only difference between auto and register is their storage. Auto gets stored on stack and register gets stored on CPU register. So then first question comes in mind, what difference does this make when we store on stack and when we store on CPU registers? So since CPU registers are on the CPU itself, so their loading time is 0. It is already there on CPU register. Whereas if your variable exists on main memory, then first you need to load it to CPU register and then it will be operated. So we save a lot of time moving the value from main memory to your CPU register. That's why register variables are faster than regular variable or any other type of variables. But as I said earlier, even though you declare any variable as register, it is not guaranteed that it will be created on the register. System will only try. And also, since we have very limited number of registers, you cannot create all the variables as register, plus you cannot create big size variables on register like array. So let's see the example of register variable. So in this code, if I simply change the type to register, my a will be, system will try to create this variable. When we run this code, system will try to create this a on register. That's it. You won't see any other difference in behavior. So only thing, if you want to really understand whether really this code has executed faster than the previous one, then you must do some profiling to find that out. I will explain profiling in some later videos, but today we will just assume that okay, this variable will be stored on register and it will work faster than auto variables. Our third category is static. Static variables storage is divided in two parts. One is BSS and another one is data. So while declaring, if you create your static variable without initializing it, that will go into BSS section. So if you don't initialize static variable, they will go into BSS section, and if you initialize the static variable, then they will go into data section. Scope is again at block level only. Lifetime is throughout your process or programs. So till your program is running, you can access this variable. The value of this variable will be retained. Default value for uninitialized static variable is 0. This is guaranteed. So if you forget to initialize your static variable, it will be set to 0, and this is guaranteed behavior. So let's see our static variables, how they work. So first part, we will see what happens if we initialize and when we don't initialize. So in this code, I'll simply make this static. For now, I will simply delete this part and I will not initialize it. So as I said, default value for static variable is 0. So we got the 0. So if you don't initialize your static variable, it will go into BSS section. Now let's see if it really goes there. So how do we find that? There is a utility called objdump. Mostly it is available on all Linux variant. So what you need to do is objdump, use the flag -d and give the object or executable. So we got our executable a.out. If I run this much, it is going to give me all the details of all sections. This is our object file. This is how it looks like. So if I look for .bss, so we got over here and we got our variable over here. That's how you can confidently say if you don't initialize, it will go into BSS section. So let me create another variable, and this time we will give some big name like uninit static, and another variable will create test. Okay, I created two static variable and I am not initializing them. I must comment this part. I am not interested in printing this. So now if I compile this and run the objdump, now see this. This was our second variable test to .1, and this was our uninit static. Okay, so both came into BSS section. Okay, so we have seen where uninitialized static variable goes. Now let's see what if I initialize it. Let's say I initialize test with some value. I it could be anything. The moment you initialize it, it should go into data section. So I'll first check BSS. So I did not initialize an init static variable, so it is still there in .bss, but test is disappeared from here. So I'll search for data. This is raw data, ignore it. This is our .data section. So if you see here, that is where our test variable came, and it is having our default initialized value 5. If you initialize, your static variable will go into .data. If you don't initialize, it will go into .bss. So we have seen storage of static variables, their default value. Now let's see their scope and their lifetime. To see scope of static variables, let's declare it within a block. What I will do, I'll simply put this thing within a block, and I will just try to print it outside that block. So with this much, it should throw me an error. Okay, so scope of static variables is within a block. You cannot access static variable outside the block. Now comes the lifetime, till when this variable will be stored in the memory. So I said it will be throughout the program. Now to demonstrate that, I will use function. So here I am creating one function name showStatic. I will cover function in separate videos, so don't worry about it. Just assume that this is how you can create some function. I'm using it to show you the lifetime of a static variable. So I have static int a. I will say a++, and I will print. To show the real difference between static variable and regular variable, I must create two copies of so to show the difference between static variable and regular variable, I will create another function non-static, and it will be just simple plain int a, and I will do a++, and I will print So what I'm doing here is I am having one copy of static function which will operate on static variable, another copy will operate on non-static variable. Both I am initializing with 0. So now let's see what happens. So first I will run the code by calling this non-static function 2 times. Let's see what happens. So both the time it is printing 1 over here. So it does not retain the value of a, it does not holds or store the variable after the block. As soon as this block is over, it will destroy this variable. This is our regular variable. Now let's see what happens if I do the same thing for static variable. So I will call static version of the function. See here, it is printing 1 for the first time because variable was initialized with 0. So for first call of static function, it declared and initialized the variable a with 0, and then we incremented by 1 and we printed, so it has printed 1 over here. For the next call of the same function, since a is already declared and initialized, it will not go again and declare the same variable. It will use the same. So for the second call of the function, it will not create a new variable. It will use the same existing variable a, and since it was modified last time and value was 1, so now this time if you do a plus plus, it will just increment the value to 2, and that's why it has printed 2 over here. Let's call one more time just to be sure. See, it is keep incrementing, it is retaining the value of previous call. So we have seen scope and we have seen the lifetime of static variable. So that is all about static. Now let's come to global. Global variables are, again, they will be stored the way static variables are stored. If you initialize, it will go into data section. If you don't initialize, it will go into BSS section. Scope of global variable is across multiple files, or you can access it from anywhere in your code. Lifetime of global variable is same as your static variable throughout the process lifetime. And default value of global is again 0. Only difference between global and static is their scope, from where all you can access your variables. Static within a block, global anywhere. So let's see, this is in program. I'll just simply delete all this. To create a variable as global, you need to create it outside of all the blocks. So this is our main block. For example, let's say if I have some function like this, then global should be out of that also. It should not be within any block. If you create within any block, it will be your auto variable, not global variable. So I'm creating integer a, or let's give some name, global var, and I'm not initializing it for now. This is one block and I will print global var over here. And I will also print, let me first give some value to this, and then I will print it. Okay, so what I have done here, I have declared one global variable named global underscore var. I am using this within one function and main function, and even if you want, you can have something like this. So I have declared global variable over here. I am using this in show method. I am just printing the variable global var, and I'm also using global var in main function. First I'm modifying the value to 10 and then I'm printing it. And to see how it behaves with the nested block, so I have created one more block over here and I am modifying the value to 5 and printing it. Sorry, there is a spelling mistake over here. It's a var, not val. Same goes here. Okay, so now let's compile again. It's compiled successfully. Now run this. So see, in main function, first we set the value of global var to 10, so it has printed 10, and in nested block I have set the value to 5 and then it is printing 5. Another interesting thing would be, what if I call show from here? So this variable I have modified over here to 10, it printed me 10, then I modified it to 5, so it printed me 5 over here. Now I'm calling show. So current value of global var is 5 because we modified that to 5 over here. So if I'm right, show will print you 5 on this line. You should see show function global var equals to 5. See, first it printed 10 from main function, then 5 from nested block, and in the end when I called show method, it printed me 5 from the show function. You can see clearly here that whatever modification you do to your global variable, it is going to retain that value. Now let's see where this variable will go. So since we declared our global variable as uninitialized, so it should go into .bss section. Let's see if it really goes there. Look for .bss. So we got our global var over here. Global variable also comes to BSS if you don't initialize it, and it doesn't matter whether you really in the later stage of the code, if you really change the value or assign the value of global variable to something, it won't change its storage section. It will be in the BSS if you don't initialize while declaring. And if I just simply initialize it, maybe let's do 10, then it should go into .data section. See, in .data global var came here and it is removed from BSS section. So we have seen storage of global variables. Initialized variable will go into data, uninitialized will go into .bss. We also saw the lifetime. So we have seen initialized global variable goes to data section and uninitialized global variable goes to .bss. Now let's see, I don't think I have shown you default value. So if I don't initialize global variable and if I call so if I just simply so what I'm doing here is I'm printing without assigning any value to global var. It is not initialized over here and I'm printing here. So it should print 0 for this statement. See, so if you don't initialize, global variables will be initialized to 0. Now let's see how global variables can be accessed across multiple files. So we have already seen that global variables can be accessed within a file anywhere. So we saw we can access it within a function, within main function or nested block. But now let's see, can we really use them or can we really access global variables across multiple files? So for that I will first create a new file and I will call test1.c. First thing you need to do is you need to declare your variable. To access global variable which is originally defined in some other file and you want to use or you want to access in some other file, what you need to do is you need to use extern keyword. Extern, then original declaration which was in our case global var. That's it. If you do this much declaration, while compiling this file, compiler will assume that this global var has already been defined somewhere in the code, maybe some in some other file. So as long as you compile this file, it will not give you any problem. So let's just print this. So what I'm doing here is I'm just printing the value of global var. I'll remove this a.out and I have two files here. One is test.c, another one is test1.c. So if I simply do gcc test1.c, then it will give me error. Why? It will give me error for linker, that undefined reference to global var. It is not undeclared variable. Variable was declared. Only thing, it did not find the definition of that variable. If you are using extern and you are trying to run gcc like this, it will try to generate the executable for test1.c, and it cannot do that until unless you have all the definition available for all the variables and functions. So since we are using extern here, it is only a declaration, not a definition. It will not compile your code. It will not generate the executable out of it. So what we should do in this case, there are two ways. One, compile both test1 and test.c here together, like this. So if you do that, see, it has compiled both test1 and test.c and it has generated one executable out of both C code. So this is your final executable. That's how you compile multiple files together. Another way of doing the same thing is use only C. -c is just to only compile. If you do that, test1.c, then also it will not give you error because it is only compiling, it is not linking your variables to their definition. So in this way you will be able to assure that okay, my code is syntactically correct. So what it has done, it has generated you a .o file, and then if I do test.c and I do test1.o, so what I'm trying to do here is I'm compiling this test.c by giving this .o file in support. So it will use this object file and it will generate the final out file. So another way to compile both files and generate out file or executable file is you can compile separately. So I will do gcc and I'm using -c to compile only, and I will do test1.c. It will give me test1.o. Same thing you can do with test.c also. So it has given me test.o. Now you can generate the final executable by mixing both object file. See, so it has given us .out file. So here if you see, when I compiled this test1.c, it did not give me any error. Why? Because we are only checking syntax in compile time. We are not creating any executable, so it will not try to bind the variables to its definition. If it is declared, it is good syntactically, it will compile your code. Okay, so now we need to do one more modification in test.c, and that is I will just call so one here. So I will just call so one here, which was declared, which so I will call so one here, which is defined in test1.c. So I will compile both files at a time. So actual function name is so_2, so I must change that in test.c where I'm calling it. So with this much, if I compile again, it should compile, and this warning is because we are not declaring it in test.c where we are actually using it, but when it is compiling both the files together, it will be able to find it. So that's why it is a warning, not a error. If you want to remove this warning, all you need to do is you need to just do a declaration of function like this, and with this much, if I compile again, the warning will be gone. So it has generated our out file. If I do a.out, so see this. This is from our test.c. Global value was 0. In nested block it printed 5, and then this one is coming from our test1.c. So that's how you can access global variable across multiple files. You have to use external keyword over there. So we have seen storage, we have seen scope, we have seen lifetime and initial value. So with this much we have covered all our storage classes. So now there is a special case. What if I make my global variable static, which is called as static global variables. Let's see what happens when we make any global variable static. In this code, all I will do, I'll make this global var as static. If I compile this code, so now if I compile this code, it is giving me error again. Where it is giving me error? In function show_2, which was defined in test1.c. So now this linker is not able to find the definition of global variable in test1.c. So that means if you make any global variable static, that will limit the scope of that variable within that file. You cannot access that variable outside of that file. So this is very important type, and in interviews this will be asked. So keep in mind, global variables can be accessed across multiple files, but if global variable is static, so scope will be limited to that file. Within that file you can access within any block, there is no restriction on that, but outside of that file you cannot access global static variables. So this is about static global variables. I have covered all the storage classes here and also a special case with global variables. I hope it will make your concept about storage classes clear. If you have any doubt, post your queries in comment box. I will reply those. Thanks for watching.